Hey, so today we have our final lesson of the year, our final new lesson, which is kind of sad because it ends kind of in an anticlimactic way, but we're going to finish out with the trig ratios, and we're going to use word problems, or what we call verbal problems, um, to use those trig ratios to solve for unknown sides or angles. Okay, so the first step in these problems is read the problem carefully. Okay, just like any other problem, please read instructions, please read the problem, because you're going to avoid a lot of issues with that. And then secondly, we're going to draw diagrams. The last problems we've had triangles where we could see, oh, I need that side or that angle. While on these word problems, if you don't diagram anything, you don't know what you're really looking for, or you're kind of confused. So the first word problem we're going to look at, here it says, the shadow of a building is 22.5 feet long when the rays of the sun make a 67-degree angle with the ground. How tall is the building? All right, so I'm going to draw a very crude sketch here. Here's a building. Here's your sun. And then it'd say this. This building casts a shadow that is 22.5 feet. 22.5 feet. When the rays of the sun make a 67-degree angle with the ground. So here, this angle right here is 67 degrees. Then they ask, how tall is this building? How tall is this building? So I need to find x. So do you guys see that I have my right triangle right there? So I have 22.5 feet from here to here, that shadow, and then I have this hypotenuse, and then I have the height of the building. Okay, so here what I'm going to do is I'm going to use this angle, 67 degrees, to find that missing side, kind of like we did yesterday. So I can either use sine, cosine, tangent. Okay, what you're going to start feeling, guys, is that you're going to start recognizing, wait, I don't need to use tangent, or I can't use cosine. So let's think it through before we pick which ratio we're going to use. Okay, here I have my 67-degree angle. Do I have the hypotenuse? Do I have the hypotenuse? Any number with the hypotenuse? No. So automatically I'm thinking to myself, oh wait, if I don't have the hypotenuse, sine and cosine, I don't have half of that. I don't have half of sine and cosine. But I do have this adjacent side and this opposite side of 67. So I have opposite and I have adjacent. Which ratio would deal with those two? Well, it would be tangent. So tangent is opposite over hypotenuse. I'm going to use tan of 67. And let's see if this really works. Opposite over adjacent. Okay, so now I have enough to solve for a missing side. So I'm going to go ahead and use my solving skills. So if I know that x is on the top, remember if it's the variable on the top, I'm going to multiply both sides by 22.5. And this is what I'm left with. 22.5 tan 67 equals x. So I'm going to go ahead and put that into my calculator. And I get 53. 53. Okay, so what that means is that x is 53. So x is 53. And what was 53 referring to? Feet. And that's how tall the building is. It's 53 feet tall based on these trig ratios. Okay, so that's how we're going to figure out these missing sides and possibly missing angles. But you have to draw a diagram or you don't know what you're looking for. Okay, let's do another one. Kind of similar to this one with the building and that kind of diagram, but here's the word problem. The base of a ladder is placed at a 66-degree angle with the ground. If Ramon is using a 20-foot ladder, how far will from the house should the base be placed? How high will the ladder reach up to the house? Okay, so here I have a house. Okay, so it's one of those long straight up houses. And he's using a ladder. So here I'm going to do a ladder. Okay, here's my ladder. And it says how far from the house should the base be placed. So the base of the ladder is the bottom. So how far should this be placed? We'll put this as X. And then he wants a 66-degree angle. A 66-degree angle. And how tall was the ladder? The ladder was a 20-foot ladder. So I know that that ladder, this right here, is 20 feet. So think of a ladder, you're placing it to go up to this part of the house. You want to put it at a 66-degree angle. By the way, like if you put it too far out, the ladder's going to fall down. That's bad. If you pull it too far in, it's easy to topple over as well. 67 degree, maybe a good measurement for that ladder. So how far can he go out, or should he go out from the house to get that angle? Okay. Let's look at finding this x value. Okay, so I'm going to use sine, cosine, and tangent, right? This is the right angle, of 67. All right, 66. I have an adjacent side and I have the hypotenuse, right? Or I'm listed with the adjacent and with the hypotenuse. So which one deals with adjacent and hypotenuse? Well, that's cosine. So I'm going to use cosine of 66 degrees equals, okay, let's see, adjacent over hypotenuse. Adjacent over hypotenuse. So I have that little equation. So I'm going to multiply both sides by 20. 20 cosine 66 degrees equals x. And that's going to get me my x value. So 20 cosine 66, 8.13. I'm going to go with, rounding to the nearest tenth, 8.1. So x equals 8.1 feet. 8.1 feet. So that was one answer. They also want me to tell them how high will that ladder go. Maybe we call this y. How far will this ladder go up the house? So how far could this go? Okay, again, I would use, okay, technically you could use Pythagorean theorem, right? This squared plus this squared equals that squared. But what if I got that wrong? I don't want to use it. So I'm going to use what they gave me as much as I can. So here, I'm going to use sine, cosine, or tangent of 66. All right, so I want to find the opposite, and I already know the hypotenuse. So what's going to deal with the opposite and with the hypotenuse? Sine. So we'll go with sine of 66 degrees is equal to, all right, opposite, which is y, over hypotenuse, which is 20. And that gives me enough to solve for this equation. So I'm going to multiply both sides by 20. 20 sine 66 degrees equals y. So that's all I need to put into my calculator. 20 times the sine of 66, 18.3. Y equals 18.3 feet. So that tells me how tall or how far up the ladder will go and how far I can go from the base to the house. So I can solve multiple parts of a right triangle. And guys, just, I mean, if you really thought about it, right triangles are everywhere. So these trig ratios can be applied to many different, I mean, I'm looking around at my room, I'm thinking there are a lot of right angles, which means I can form a lot of right triangles, which means I can know a lot of different sides. In fact, if I'm looking at this board right here, this board is a giant rectangle, right? And let's see if I can come up with a problem with a giant rectangle. Did I have one here? I think I had one on your worksheet that I'm going to go with. Okay, here we go. So here's the last word problem that I'll give to you. It says, the sides of a rectangle are 25 centimeters and 8 centimeters. What is the measure to the nearest degree of the angle formed by the short side and a diagonal of the rectangle? Whoa, that's a lot of info. So I'm going to start off by drawing a rectangle. Like, that's all I'm going to start off with. It says the sides are 25 and 8. Okay? And you're like, how do you know which one was which? Well, the length is going to be the longer side, the width is going to be the shorter. And so this is 25 and that's 8 if you really needed it. Okay, And what they say here is, sorry, I lost my place. What is the measure to the nearest degree of an angle formed by the short side and the diagonal of a rectangle? So here's a short side, and here's one diagonal. So I'll do a kind of tick mark. That's a diagonal. It's saying, okay, with this short side and this diagonal, you form an angle. What's that angle going to be? X degrees, I don't know. Just by using this info right here. Okay, and you're like, I'm not sure what to do with that. Okay, ready? This is a right angle, and we're dealing with this triangle right here. So I'm trying to find what's this angle. So I'm going to use my sine, cosine, and tangent, but I don't have an angle. So we're gonna put it into our calculator a little differently, but we're still going to look at opposite hypotenuse, adjacent hypotenuse, or opposite adjacent. Okay, look at angle X, the one we're trying to find out. What sides do we have compared to angle X? We have adjacent and we have opposite. We don't have the hypotenuse. So what's going to deal with opposite and adjacent? It's going to be tangent. Here's what I have. Tangent of X, right? I don't know what X is. Excuse me. Those allergies. But I do have opposite over adjacent. I have 25 over 8. Okay, in this problem, which is kind of nice, I don't have the angle, so I don't have to solve. I'm trying to solve for this right here. So if I could simplify 25 over 8, 25 divided by 8, I get tangent of X equals 3.125. Okay, that's all I have. That's all I need. So I don't know the angle. Remember how I put that into my calculator? Instead of pressing tangent of, for example, 3.125, why don't I put second tan or inverse tangent of 3.125? And that gets me to the nearest degree, 72 degrees. 72 degrees. So this angle right here is 72 degrees rounded to the nearest degree. And that's the angle formed by that diagonal and that short side. They could have asked, what about the diagonal and the long side, which would have been this little angle, but they didn't ask for that. So just make sure you draw a diagram, make sure that you work these problems out, and if you have any questions, please ask on the Google Classroom, and or tomorrow we'll also have an optional Zoom session. So what I'm going to give you for homework is I'm going to give you numbers 1 through 5 on the worksheet that I am attaching to your assignment. So numbers 1 through 5 on worksheet. And again, I will attach that and I'll write that up on Google Classroom. So do those problems. You don't have to turn them in on that worksheet. Just work them out like you did on a normal homework. You put on your own piece of paper, draw your diagrams, show me your ratios, and then work them out. You can use your calculator, but you guys show me your work. All right, guys. I hope you have I hope you're able to do these. I hope you're able to see the diagrams. And again, if you have questions, please let me know. And I'm so sad to say this, but this is our last lesson. And we'll review for our tests, but on Friday, which, by the way, guys, it's going to be assigned on Friday, but I already saw that you have a lot going on Friday, so I'll give you some flexibility on when to turn that in. But please be honest with your work, and I'll see you guys later.